In this video, we're going to work practice problems involving the multiplication of power series. So, all right, what we want to do is, so for this first example, and every other example will be similar to this, we want to find the first three non-zero terms of the power series of this function. Okay, and so the idea is we can't just, get the power series for cosine x or the power series for e to the minus x squared and then multiply that power series for e to the minus x squared, for example, multiply that by cosine x. I mean, you could do that. There's nothing wrong with that. Like, that's valid. And you could, bring the cosine x in. That's fine. But the problem is you're not left with a power series. Once you've simplified, it's not a power series anymore, right? If you think about all the problems we've worked, we might have had x cubed minus 3 cosine x over x to the fifth, etc. And once we did all of we subtracted in the x cubed divided by x to the fifth, and we finished simplifying, we were at the end of it all, we were left with another power series. That was the key. When we differentiate the power series, integrate, then multiply by x, whatever, we're left in the end with another power series. If we did this, we get, some c sub n cosine x times x to the n. That's not a power series anymore. Now, maybe if you went into further math classes, more advanced math classes, you could do some analysis with something like this, but that's beyond the scope of this course. Okay, so what can we do with this? Well, we can think about multiplying this power series by this power series. Okay, and so in the video where we went through this part of the section on multiplication and division of power series, we talked about how to multiply two power series. So what we've got is, okay, so y is equal to, we're not going to derive the power series for e to the minus x squared. We've done stuff like that plenty of times. All we would do is use this and plug in minus x squared. And this comes out to okay, there's e to the minus x squared, and then cosine x is so minus 1 to the n times x to the 2n over 2n factorial. Okay, so these two are equal. Y is equal to this, and so we haven't changed the equality. Now, I am curious why we can't just multiply these two a sub n's. The textbook doesn't talk about that, but apparently you can't do that. It just doesn't work that way. So, yeah, and the reason it makes sense because what you're having to, it's like the full foiling, right? You can't, like I can't do, when you multiply a plus b plus c by, let's say, d plus e plus f, I mean, you can't really just, I don't know if that's the best example, but you have to distribute each term. So, I guess it just doesn't work out that way. It'd be interesting to watch a video that talks about why you can't just multiply the two a sub n's. But so what you have to do is this, though. The way to do it is so we're going to write out the expanded form of each of these. Okay, so the first term here is, let's see, 0 factorial is 1, x squared, x to the 0, so just 1. Okay, then we're going to have minus, and then 1 factorial, then x squared, so minus x squared plus, okay, let's see, x 2 times 2 over 2 factorial, so 1/2 x to the fourth. And let's go one more. So, okay, 3 factorial is 6. So it's going to be 1, 6, x to the 6th. And you just do however many, how many terms you write in the expanded form depends on how many terms you want for the, we're getting the first, it wants the first 3 non-zero terms of the multiplication. So if you wanted more terms than that, you would write out more terms here at this step. Okay, n is equal to 0. You've got, looks like just 1. And then n is equal to 1. You've got 2 factorial, so 1/2 x squared. Okay, n is equal to 2. You've got 4 factorial. 4 times 3 is 12. 12 times 2 is 24. Okay, x, 2 times 2 is 4, minus, okay, 3, n is equal to 3. You've got, so 3 times 2 is 6. 6 factorial is, so 5 factorial is 120. 120 times 6 is 720. So 1 over 720, x to the 6th. Okay, and we're probably not going to use all of these terms. Okay, so now next what we're going to do is we're going to write these in 2 rows and match up the order, the terms that are in have the same order. And it looks like for this, in this situation, they're going to be automatically aligned anyway. So you've got 1 minus x squared plus 1/2 x to the 4th, and that should be, to get the first 3 non-zero terms, that should be all we need, because, so, okay, we do the same thing here and we line up. So 1, if this was like x cubed, let's say, then we would have to put like a 0x cubed placeholder here, or no, it would be here, and then line those up. But we don't have that here. Okay, so we're multiplying these two. So next what we're going to do is go term by term here. So we're going to do 1 times this, and times this, and we're going to write it out like so: 1, and then minus x squared, and then plus 1/2 x to the 4th. I'll just put a plus here. I mean, technically just put a plus here because we don't know what terms are coming next. They're going to be negative, but this is more general. Just put a plus. Okay, but the way you do it, though, you don't, like, if we had, so, okay, the next row we'll do, so, like, okay, we're going to come to this term next and do minus 1/2 x squared times each of these terms. But, okay, minus 1/2 x squared times 1 is minus 1/2 x squared, but we don't put that here. We always line up the order of the x terms. So minus 1/2 x squared, and then 1/2 x squared times x squared. Well, minus 1/2 x squared times minus x squared is positive 1/2 x to the 4th. So hopefully in upcoming examples, what we can do an example where the orders of the x's don't match up quite as nicely as this. So you could get it. They'll give you a better feel for how to do this. But okay, but we're done. Because next we would do 1/2 x squared times this term, but we're omitting, we're not going that far because we're going to have 3 non-zero terms here. Okay, so we're going to do now multiply this times all 3, and we get 1/24 times x to the 4th, or 1/24 x to the 4th times 1, positive 1, is 1, and that's it. Right, because if we did the x squared, we get the 6th power, so that's it. You get, this is always going to be just 2 rows because you're multiplying 2 separate polynomials. This is going to be however many terms you've got. Like if you have 3 terms drawn out, like 3 places, like 1, 2, 3. If we went to the fourth term here, we had an x to the sixth, then this would be 6 rows because you do that multiplication for each term. Now we add this. Okay, so we got 1 plus 0 plus 0, all right, minus x squared minus 1x squared minus 1/2 x squared is minus 3/2 x squared. 1/2 plus 1/2 is 1 plus 1/24. So 24 over 24 plus 1 over 24 is 25 over 24. So plus 25 over 24 x to the fourth. Okay, and that's it. So you could write this as this is approximately equal to 1 minus and don't even put the plus dot dot dot. If you put plus dot dot dot, then they would be exactly equal. But you could keep going out to as many terms as you need until you can see a definitive pattern. But even then, the textbook doesn't talk about. It seems like the textbook gives examples where we identify patterns and then turn that into a summation, but we don't actually officially prove that that pattern is true for all n. But you could easily do that using induction. Go check out the videos earlier in this from chapter 11 talking about induction, showing how to use induction. So if you could do like more terms, and then if you could find an actual formula for the coefficient for the sum, that's most likely correct. If you have like a bunch of terms and if you could get the formula for the first 5 or 6 terms or even more than that, then it's most likely correct going all the way to infinity, but you could still prove it using induction if you needed to. But here we're just, still this is, I'm sure it's probably pretty accurate anyway, right? But you could easily go farther if you needed to. But that's the first 3 non-zero terms this is e to the minus x squared times cosine of x is approximately equal to this. This is the first 3 terms of the resulting power series, or of the actual power. These are the first 3 terms of the actual power series of this. Okay, so e to the x is what? And sum from n is equal to 0 to infinity x to the n over n factorial. Okay. Times natural log of 1 plus x should be sum from n is equal to 1 to infinity, or it might be 0 as well. No, n is equal to 1 to infinity minus 1 to the n minus 1 times x to the n over n. Okay, so now let's write this out in expanded form. So n is equal to 0, you've got 1. N is equal to 1, you've got x. N is equal to 2, you've got 1/2 x squared. N is equal to 3, you've got 1/6 x cubed. N is equal to 4, you've got 1 over 24 x to the fourth. Okay, times, okay, here n is equal to 1. You've got, this becomes positive. You just got x. N is equal to 2. This is negative. You've got 1/2 x squared. N is equal to 3. You've got 1/3 x cubed. N is equal to 4. 1/4 x to the fourth. Okay, so we've got 1 plus x plus 1/2 x squared. Okay, and that should be, let me just go one more. I think that would be enough, the first 3, but it might not be. So, okay. Now here we line up the x to the first minus 1/2 x squared plus 1/3 x cubed. I'm just going to put a plus here because it's like general. There's plus and the rest of it, but it would technically be a minus. Okay, so we're multiplying these. Now we just go term by term. So x times 1 is x. X times x is positive x squared. Line these up. X times 1/2 x squared is 1/2 x cubed, positive 1/2 x cubed. Okay, now we come here, minus 1/2 x squared times 1 is minus 1/2 x squared. Minus 1/2 x squared times x is minus 1/2 x cubed. Okay, now 1/3 x cubed times 1 is 1/3 x cubed, and that's it. If we continued on, then we were multiplying 1/3 x cubed times each one of these. Okay, and so that's it. Now we want to add these. So we've got so there's no 1 here. This is 0, right? There's nothing here. So we've got x, and then 1x squared minus 1/2 x squared is plus 1/2 x squared. And then 1/2 minus 1/2 is 0. So this is plus 1/3 x cubed. And there we go. So this is approximately equal to x plus 1/2 x squared plus 1/3 x cubed. Okay, so here we're actually going to do 2 multiplications. So let's first do sine squared of x. So sine of x is sum from n is equal to 0 to 1 minus 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. So, okay, sine squared of x is equal to sum from n is equal to 0 to infinity minus 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial, okay, times, once again, okay, so we can write this out in expanded form. When n is equal to 0, you've got x to the first over 1 factorial. Okay, then minus n is equal to 1, you've got x cubed, and then 3 factorial, so 1/6 x cubed. Then plus, okay, minus 1 squared, 2 times 2 is 4, so x to the 5th, 5 factorial is, okay, well, let's, just to make this easier, let's leave the factorials. X cubed plus, okay, minus 1 over 7 factorial x to the 7th. Okay, and then the exact same thing. Okay, so x minus, okay, and then all right, so we're multiplying these two. All right, x times x is x squared. So, okay, yeah, here we go. All right. So actually, let's come back. So, okay, plus 0x squared minus plus 0x to the fourth okay, okay, so we're multiplying these two. Okay, x times x is x squared, and then x times 0x squared, that's just 0. So then now x times this is 1 over, well, no, that's going to be x to the fourth. So we just do this. So x times 1 over 3 factorial x cubed is minus 1 over 3 factorial x to the fourth. And then x squared times 0x to the fourth is 0. So, okay, that's it. Now we skip this. Then 1 over 3 factorial x cubed times x minus 1 over 3 factorial x cubed times x is minus 1 over 3 factorial times x to the fourth. Okay. Then this doesn't give anything, so we don't have an x to the fifth term, and then x to the sixth, we're not going that far. Okay, now this is, so 1 over 5 factorial x to the fifth times x, we get an x to the sixth, but we're not going that far. But the problem is we're only going to have, if we stop, we're only going to have two terms. So let's continue on, actually, and do this. So, all right, minus okay, so now if we kept going here, you have x to the sixths, and then here x to the seventh. So 1 over 5 factorial times x to the seventh, positive. So, okay. Wait, no, that's not right. Hold on. We did x times x squared, and then we multiplied this, then this. This was x to the fifth. Now, x times 1 over 5 factorial x to the fifth is going to be an x to the sixth term, and I forgot to put so, okay, plus, okay, minus, okay, so the x times 1 over 5 factorial x to the fifth is going to be positive 1 over 5 factorial x to the sixth. And we're not going to go past, we're not going to go to x to the seventh, so we might not have even needed this. Okay, now here, 1 over 3 factorial x cubed, you got the x to the fourth term, and then here's the x to the sixth term. So this is going to be positive 1 over 3 factorial times 3 factorial x to the sixth. Okay, and then there we go. We can stop there. Because even, well, no, we have to do this. 1 over 5 factorial times x to the fifth times x is plus 1 over 5 factorial x to the sixth. So now there's no more multiplication we can do to get something that's has a power of x to the 0, x to the first, x to the second, or x to the, all the way to x to the sixth. So, okay. Now we want to add all this. So we've got x squared minus this is going to be 2 over 3 factorial x to the fourth. But minus 2 over 3 factorial x to the fourth. Okay, and then you've got 2 over 5 factorial plus 1 over 3 factorial times 3 factorial x to the 6th. This is positive. Okay, so we'll do this. So approximately, for the multiplication, we're going to use x squared minus, so 2 over 3 factorial is 2 over 6. That's 1/3 x to the 4th. Then plus, okay, so 2 over 5 factorial is what? 2 over 5 times 4 is 20 times 3 factorial plus, so we can take out a 1 over 3 factorial, and we're left with 2 over 20 is 1 over 10, plus 1 over 3 factorial is 1 over 6. So 1 over 10 plus 1 over 6 is what? So 6 over 60 plus 10 over 60 is 16 over 60. 6 divided by 2 is 3. 8. 8 divided by 2 is 4. 6 divided by 2 is 30. Okay, so that's 2 over 45. Okay. 2 over 45 x to the 6th. Okay. All right, so e to the x times sine squared of x is equal to what? So what is e to the x? So from n is equal to 0 to infinity, x to the n over n factorial, 1 plus x plus 1/2 x squared plus 1/6 x cubed, etc. Okay? So 1 plus x plus 1/2 x squared plus 1/6 x cubed plus 1/24 x to the 4th. Okay, now we're multiplying this times x squared minus 1/3 x to the 4th plus 2 over 45 x to the 6th. And this would go on, you know. So we've got 1 plus x plus 1/2 x squared plus 1/6 x cubed, and that should be good. And maybe not, actually. Yeah, let's go a little bit more. I mean, it doesn't matter how many you write here. Plus 1/24 to the 4th. Okay. Now, x squared, line up the x squareds, minus 1/3 x to the 4th. And that's all we can put. Okay. So we're multiplying these two. X squared, just go through each of the terms. X squared times 1 is x squared. Put that here. X squared times x is x cubed, positive x cubed. X squared times 1/2 x squared is positive 1/2 x to the 4th. Okay, we're only going to have 2 rows here because we've only got 2 terms. So minus 1/3 x to the 4th times 1. Start at the first. You know, you start here, is minus 1/3 x to the 4th. Okay, and that's going to be it because we're not going to x to the 5th. That's fine because we're going to get 3 terms. So, okay, you add these, you get x squared plus x cubed. 1/2 minus 1/3 is, so, okay, 2 over 2 times 1 over 2 is 2 over 4 minus, wait, no. Okay, so 3 over 3 times 1/2 is 3/6. 2 over 2 times 1/3 is 2/6. So it's 1/6. Positive 1/6. So plus 1/6 x to the 4th. And that's it. So the textbook writes it, they just put approximately equal to, and they put the first three terms. But you could actually put equal to and just put the dot, but I'll leave it like this. Okay, let's do arctangent of x squared. So what is arctangent? Sum from n is equal to 0 to infinity minus 1 to the n, x to the 2n plus 1 over 2n plus 1. So this is equal to the sum from n is equal to 0 to infinity okay, multiplied by okay, so y, which is arctangent of x squared, is equal to, when n is equal to 0, you've got x to the first over 1. So x, then minus, when n is equal to 1, you've got x cubed over 3. When n is equal to 2, you've got, it's going to be 1/5 x to the 5th. And then so you can see the pattern. Okay. Okay, so x minus 1/3 x cubed plus 1/5 x to the 5th, and that should be good since they match. X minus 1/3 x cubed plus 1/5 x to the 5th. Okay, we want to multiply these. X times x is, well, we need to put placeholders. So it's x plus 0x squared minus 1/3 x cubed plus 0x to the 4th plus 1/5 x to the 5th. Okay. All right. X times x is x squared. X times minus 1/3 x cubed is minus 1/3 x to the 4th. And then looks like we're going to need another placeholder out here. Okay, x times 1/5 x to the 5th is 1/5 x to the 6th. Okay, minus 1/3 x cubed times x is minus 1/3 x to the 4th. Minus 1/3 x cubed times minus 1/3 x cubed is positive 1/9 x to the 6th. Okay, and these would. Okay, 1/5 x to the 5th times x is positive 1/5 x to the 6th. Okay, and we're going to add these. So x squared minus 1/3 is minus 2/3 x to the 4th. 1/5 plus 1/5 is 2/5 plus 1/9. So 2/5 plus 1/9. 9 times 5 is 45. So 9 times 2 is 18 over 45 plus 5 over 45. So it's 23 over 45. Okay, so plus 23 over 45, x to the 6th. And let's write it like this. This equals x squared minus 2/3 x to the fourth plus 23 over 45 x to the sixth. But maybe they don't want to put this because there's no, I guess if you're going to put this, you want to say what the pattern is, and we don't say what the pattern is, but still, I don't know, right? Because what do you mean by this? Plus dot dot dot. What is that? You're not saying what that means, so it's just ambiguous. So I guess that's probably, we don't want to put that. So we're just going to put approximately equal to that. Okay.